Alright, so this is another example of the process of balancing equations. Now this one's a little more difficult, only because we have some polyatomic ions in play. Like I said before, you're going to have to commit these to memory eventually. It may take a while, but for now, use all the resources that you have. Use your flashcards, use the textbook if you need to know what these ions are. It's really important that as you're practicing, you practice the right way. So don't just guess. Always make sure you know the formulas for polyatomic ions and know how to name them as well. So here we have a reaction in which we're combining magnesium nitrate with sodium sulfate. And what we get on the other side, this is something we call a double replacement reaction, we'll get into that later, is magnesium sulfate and sodium nitrate. So basically all the ions just switch places and we have two new products. So we've already gotten the correct formula, so step one is a check. We've already arranged the reactants on the left and the products on the right, so that step's done. Now we need to make a grid, and this grid will help us keep track of the atoms of each element on each side of the equation. Now if we skip down to step 5, and I'll go ahead and make the grid while I'm talking, you notice that in step 5, we talk about treating polyatomic ions as a unit if they appear on both sides. This is a hugely helpful strategy because you don't want to have to keep track of individual oxygen atoms. Because you notice here, if you look up at the equation, that both the nitrate and sulfate ions contain oxygen. So with all the subscripts and the parentheses, it's kind of hard sometimes to keep track of what's what. So it'll really help you if you see that you can treat those polyatomic ions as a unit. So I'm going to go ahead, if that's all right with you, and just do that. So in my chart, I'm going to write magnesium, then I'm going to write nitrate. So I want to know not the number of nitrogen atoms, not the number of oxygen atoms, but the number of nitrate ions, the number of NO3s I have. And that should be pretty easy once we get the hang of it. Then, the other ions, the other atoms we have are sodium, obviously, and then sulfate. So again, I'm treating those like a unit. If you wanted to fill this in with the letter X, or whatever letter you like, I would probably pick B for Bryant, then you could do that as well. So, we have our grid, and I'm going to fill in the grid with what we already know, without adding any coefficients. How many atoms do we have of each element? So, we have magnesium here, and there's no subscript, so there's just one there, and there's also just one on the right. Now, when it comes to nitrate, remember this subscript applies to whatever's in the parentheses, and what's in the parentheses happens to be NO3. So, we know we have two nitrate ions on the left side. And obviously, since there's no subscript, we have one nitrate ion on the right side. Now, before you really commit these polyatomic ions to memory, you're probably going to get thrown by that. But you've got to start to recognize them. The more you practice, the easier it'll be. So don't sweat that just yet. Now here we have a subscript of 2 under sodium. So we have 2 sodium atoms on the left, and we have just 1 on the right. Now when it comes to sulfate, we have no subscript under either one. So we have 1 SO4 on the left and 1 SO4 on the right. So it looks like, right now, as long as nothing changes, we have all the magnesium we need, so I'm going to check that off, and we have all the sulfate we need. Now, of course, I may have to remove that check, because I may need to change something about those elements. So let's see what we can do. So for now, we'll skip magnesium because it's already balanced. We do need to do something about the nitrate, however. We have 2 on the left, as we can see, and we only have 1 on the right. Now, remember, the only way that you can change the number of atoms, or in this case the number of ions that you have, is to add a coefficient, a big number in front. We cannot change the number of nitrate ions we have in sodium nitrate. We can only change the number of sodium nitrates that we have. So, what I'm going to do is really pretty simple. I'm going to go ahead and put a 2 in front of sodium nitrate, just like that. And that changes not only nitrate, so now we have 2 nitrate ions, but it also changes sodium. Now, after each step, you want to look at the equation and make sure that you're on the right track. So, what you're looking at here is, first of all the numbers check out. And now, it looks like we have a balanced equation. So, again, after every step, check. You may be done. You may not need to do more. A lot of students, even the best students that I've had over the years, have sort of gone overboard. They think they have to do too much, and they overbalance the equation. I know that's hard to think about, but they do. So make sure you don't overbalance. Make sure you don't go too far. If it's done, if you have the right number of atoms of each element on both sides, you are finished. And it looks like we are here. So I'm going to stop talking and let you move on to the next podcast. Thanks for listening.